Alright, so this time today we're going to be putting it all together. What that means is we are going to go through the steps of factoring. We're going to look for greatest common factors. We're going to break down the leftovers. And if there's no GCF, we're going to break them down anyways. So we've got special cases where there's no middle term, meaning it's probably a difference of squares. If you're left with the same thing, please write it as a quantity squared. So I've got these broken down, and the first thing we're going to do is we're going to find the greatest common factor in this problem. So the greatest common factor here in this whole thing would be, let's see, the smallest number is 4, so I can take out a 4 out of each one of these because they're all divisible by 4, and each one of these shares an x squared in common. What that leaves me with is I'm going to end up with 4 terms. 4 times 1 gives me the 4, and x squared times x cubed gives me x to the 5th. 4 times 4, and then x squared times x squared gives me x to the 4th. 4 times 3, x squared times x gives me x cubed. 4 times 2, and then x squared, that just gives me the 8x squared. Now, since this does have 4 terms, we might try to group this. When I group those two together and group these two together, but this greatest common factor would be x squared, and I'd be left with an x plus 4. This greatest common factor is just 1, and I do not end up with the same thing on the inside of the parentheses, so I know I'm finished. This is the only thing I can do for this particular problem. Let's try another one of these. We're going to factor out, we're going to find the greatest common factor. The greatest common factor is 2 amongst the numbers. They all have at least an a squared, and they all have at least a b squared. So 2 times 2, and then I need another a to give me the a cubed and the b squareds out front, minus 2 times 3, I have the a squared, and I have the b squared already, plus 2 times 1 gives me 2, I need an a squared to get me a to the 4th, and I need b squared times b is b cubed. This is not factorable at all. It's not a trinomial. It is a trinomial, but it's not an x squared term and an x and a number. The next problem, we're always going to look for the greatest common factor first. The greatest common factor is just 1 in this problem. So what we're going to do is we're going to just break it up into parentheses. I've got x times x. Factors of 4 are 1 and 4 and 2 and 2. I'm trying to create a 4 though, so I need to put a 2 times a 2. That gives me 2x and 2x, which is both plus. Since I end up with the same thing on the inside of the parentheses, I need to write that as a quantity squared. The next problem has that special case where I have 0 on the inside. 0 on the inside is looking for what times what will give me the x to the 4th. Well, x squared times x squared. 9 times 9 is 81. Difference of squares has the minus and plus because it gives me the negative 9 and the positive 9. Now, the amazing thing about this one is that it's not quite finished because I have another difference of squares that has now appeared. This is x times x, and this is 3 times 3. Minus and a plus, that gives me the 0 term on the inside. This is not a difference of squares. See the addition sign between it, so it stays x squared plus 9. This would be the completely factored version of that answer. On the next problem, I have a 25x squared and a 64. So I have a 5x times a 5x. I notice it's a difference of squares because they're both square terms. I have 8 and 8 minus and a plus sign gives me the 0 on the inside. Let's see if I can get one more problem in. I have a trinomial. There is no greatest common factor, so I cannot take out anything from each one of these. I will break this up, so I have x times x. Factors of 36, there's a lot of those. There's 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. This is the one that gives me a 13, so 4 times 9. I need a positive 13. There's my positive 13 with a 4x and a 9x.